So let's look at this next one. If you just jumped into the example without looking at the title, you might not know the answer to this, but it says limits that fail to exist. It says in the next 3 examples, you will examine some limits that fail to exist. Different right and left behavior. Example 3 says, show that the limit as x approaches 0 of the absolute value of x all over x does not exist. You may use a table or sketch a graph of the function to show your work. So this is totally up to you. I don't care how you do this. You can use a table, you can use the graph. Of course, the only way you could use the graph is if you're using a graphing, well, unless you A, graph it yourself, or B, use something like Desmos to graph it. Now what's nice, Desmos has the ability to graph the absolute value of x. But imagine you're on the test, you don't have the option of using Desmos, so using a graph on a problem like this wouldn't actually be something you could probably do unless you graphed it by hand by yourself. Okay, so that means I'm left to my calculator and most likely left to a table. So if I'm using a table feature on my calculator, let's set up what this table would look like. Let's think about it. So you would have your x values, you would have your y values, and the y value here, you would plug it into the absolute value of x over x. We need at least 3 values from the left. We want at least 3 values from the right. We're talking about the point 0. Of course, if we plug in 0 here, 0, the absolute value of 0 is 0, 0 on bottom, so this would be undefined. So we know this is not the type of problem that you could just plug numbers into. So let's think about this. We want to approach 0 from the left, so we want numbers that are getting closer and closer to the number 0. So I'm going to use the x value, how about 0.1, close to 0, but I need it to be negative because I need to be from the left. So about negative 0.1, negative 0.01, and negative 0.001. Notice I'm getting closer and closer to the number 0. Likewise, I'm going to come from the right now. I'm going to use positive numbers now, so this would be 0.1, same numbers, 0.001, and 0.00. Sorry, this should be 0.01 on the second one. Second one should be 0.01 with just 1 0. And then 0.001, so 2 zeros. So I'm getting closer and closer to 0 from both of those sides. Now the thing is I need to plug this into the function, so how do I evaluate this as the function? Well, hopefully you remember what absolute value functions are. Absolute value functions is if the number is positive, the absolute value of that number stays the same. So for instance, the number 5, what's the absolute value of 5? The answer is 5. It doesn't do anything to it. So anytime this number is positive, the inside of the absolute value is positive, or 0, it returns the exact same thing. So if x is greater than or equal to 0, then the absolute value of x, is equal to just x. Now let's think about what if the number is less than 0? What if it's a negative number? So what's the absolute value of negative 4, for instance? Well, the absolute value of negative 4 is positive 4. So what does it do? What does the absolute value function do? It changes the sign from negative to positive. You input a negative, it outputs the positive. Again, if you input a positive, it keeps it exactly the same. It doesn't change it. But if you input a negative number, it gives you the opposite of that number. So anytime x is negative, the absolute value of x is the opposite of what you put in. You put in the number negative 4, it gives you the opposite of negative 4. Negative 4, which is a positive 4, right? So really, we've defined ourselves a piecewise defined function, haven't we? We've said if x is greater than or equal to 0, well, the absolute value of x is just x, but then this is over x, so it's just the number 1, isn't it? And if x is less than 0, the absolute value of x is negative x, but that's negative x over x, which is the value negative 1. So what we just determined is our function value for any number 0 or bigger is always going to be the number 1. Any number 0 or bigger is always going to be the number 1. Anywhere less than 0, smaller than 0, is always going to be the y value of negative 1. So if you think about as x approaches 0 from the left, my x values, negative 0.1, negative 0.01, negative 0.001. My y value is always negative 1, so this is approaching the value negative 1. And as I approach it from the right, my y values are always 1, so this is approaching the value of 1. Notice from the left and from the right, they don't agree. Since the limits don't agree, what does that mean? That means, just as the green title suggests, the limit as x approaches 0 of this function, which is the limit as x approaches 0 of the absolute value of x over x, does not exist. I'm going to write D and E for does not exist. And it says, why doesn't the limit exist in your words? I would simply say the limit from the left, the limit as x approaches 0, from the left is not equal to the limit as x approaches 0 from the right. Okay, that would be more of an official, thorough sentence here. The limit as x approaches 0 from the left is not equal to the limit as x approaches 0 from the right. Notice here you have negative 1, here you have 1, and these two numbers are different. Anytime they're different, we know the answer is does not exist. Okay. Easier words, I would have just said limit from the left is not equal to limit from the right. But you do need to say, if you want to say the limit from the left is not equal to the limit from the right, you do need to add into it as x approaches 0. So you would need to write as x approaches 0, because the limit from the left and the right are actually the same at every single point in this graph, except the very specific point when x equals 0. So anytime you want to say left is not equal to the right, you need to say at x equals and then write the x value. Let's look at example 4 here. It says discuss the existence of, let's go back, I'm sorry. Let's go back to this example right here, example 3. I just want you to go ahead on Desmos and to sketch this real quick. Let's see what it would have looked like had you done it on Desmos. Would have you been able to see this graphically? And the answer is, hopefully what you saw was something like this, where to the left it was the value of negative 1, and to the right it was the value of 1. And if you notice, there's a huge gap between these two. Those two sides don't agree. So from the left it was negative 1, and from the right it was 1. So I hope that helps you out. Okay, so let's go on to the next one. Let's look at it. It says discuss the existence of the limit. The limit as x approaches 0 of 1 over x squared. You may use a table or sketch a graph on your function for your work. Okay, so here I could use Desmos because I'm sitting here and I'm at home. I could use Desmos and I could look at the graph, but what I want to prepare you for is that test. Remember, you're not going to have Desmos when you take the test. You're not going to have that graphing utility. So how could we do it algebraically? On this one, again, I'd probably use that table. Let me get the right color here. So I'm going to do exactly what we just did on the previous problem. I have my x values, I have my y values. Again, my y value here is a little more clear though. My y equals 1 over x squared this time. Again, I'm trying to find it at the value of 0, but if I tried plugging it in, that would be 1 over 0 squared, which is undefined. So I don't know what the function value is. I don't care what the function value is at that point anyways, though. I'm going to find numbers to the left of it, and I'm going to find numbers to the right of it. I'll start off again with negative 0.1, negative 0.01, negative 0.001. I'm going to start off with to the right I'll do a 0.1, 0.01, and then a 0.001. So again, if you notice, x coming from both directions is approaching the number 0. This one I can directly put into my calculator, so I'm going to hit table, I'm going to clear out the function, I'm going to do 1, hit the n over d button, hit x squared, hit enter. Start doesn't matter, step doesn't matter, ask x needs to be selected, hit enter for OK. I'm going to put in that negative 0.1, don't forget that negative sign, negative 0.01, and then a negative 0.001. Hit enter every single time. When I do this, I'm getting the number 100. Looks like the next one is 10,000. Should have made this chart a little bigger. The last one I'm getting, what is that? Are you guys seeing 1 million? I think I see 6 zeros there. I apologize for making my chart a little too small. I'm going to zoom in to help me on the next one. I'm going to do it on the right ones. I'm going to put in 0.1, enter, 0.01, enter, and then 0.001, enter. I'm ending up with the exact same values. I have a 100 when I plugged in the first number. I have a 10,000 when I plug in the next one. And then, yeah, it seems to me that that's a million as I plug in the next number. So let's talk about what's happening. As I approach 0 from the left, so I'm looking at 0 from the left, what's happening to those y values? Well, it seems to me 100, 10,000, a million. It seems to me that this is growing without bound. And WO here stands for without bound. And that means it's approaching infinity. It gets bigger and bigger and bigger. So as I approach 0 from the left, it looks like it's approaching infinity. Let's come in from the right again. I went 100, a 10,000, a million. Again, it's also growing without bound. It's the exact same thing, right? Which tells me that it's also approaching infinity. So does the limit exist? Well, no, it doesn't exist. It kind of does. You kind of want to say the limit equals infinity, but let's think about this. Would I say the limit as x approaches 0 of 1 over x squared equals infinity? Well, yeah, I can say that. A lot of textbooks would actually allow that, but that's actually technically not correct, because could you ever actually equal the number infinity? And the answer is no here. No, infinity is a never-ending number. It's never something that you can actually equal. So what would you say here? You would say it grows without bound, or it approaches infinity. It's a little bit of a bastardization of the equal sign to actually write infinity. But it says, does the limit exist? Well, if you remember, for a limit to exist, it needed to approach the single number L. Infinity is not a number. I mean, it kind of is, but it's more of a concept. It's not like you can reach the number infinity. So the question says, why doesn't the limit exist? Well, we would say the limit is infinity, but we would say it doesn't exist because it doesn't approach a single number. Here emphasizing the fact that it's a number. It grows without bounds. Okay. It says throughout the semester we'll have several opportunities to do interactive examples online. These examples require that you install the Wolfram Player. I wouldn't do this on your cell phone at all. I would only do this on your computer if you have a computer. There's a Wolfram Player that you can download. It actually turns out to be pretty dang big. But it says to install the free Wolfram Player, please go to www.wolfram.com/player, and then you can download it. It says there's also a version for the App Store on iOS devices such as iPhone and iPad. I'm pretty sure that they have it for Android as well. You can look it up. I have an iPad, so that's what I'm teaching with, so that's what I downloaded it on. Okay, so what's the point of these? Why would you want to see these interactive players? Well, these interactive players, what they let you do is they let you actually physically move things around so you can visually see what's going on. Is it absolutely necessary that you download them and use them to complete these problems? No, it's not absolutely necessary, but man, it does help sometimes to visually see what's going on. So if you have your own computer, I'd highly recommend downloading that player, because what I'm going to do is provide links for you in these notes. You can open up that Wolfram CDF file, download it, open it up using the player, and you can actually play around with it and see what's going on. Again, is it required? No. Is it strongly suggested, yes, that you get this Wolfram CDF player. But you still are able to solve these problems even without that CDF player. So if you don't have access to a computer, don't worry about it.